Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to determine if a function is odd, even, or neither algebraically. Before we get started, we're going to take a look at the test, how to test to see if a function is odd, even, or neither. Okay, so let's take a look at the first part of the test, which is for even functions. If a function f of x is composed with negative x, and that results in no change in the function, what does that mean? Then the function is even. Think about even as the same, okay? Or equal. So even think about equal signs, equal. Now, how about odd? If you take a function and you compose it with negative x, and the result is that you end up with the opposite of the original function, then what you have is a case where f of x is odd. Then f of x is odd. Think about odd. When you think about odd, think about the word opposite. Okay? So for odd, we have opposite signs. And for even, we have equal signs. Okay? Now, if you have neither of the two of the above mentioned in 1 and 2, so if f of negative x is not equal to the original function, if it's not the same, and f of negative x is not equal to the opposite, so it's not equal to the opposite, then the conclusion is that f of x is neither odd nor even. Okay? For in this scenario, think about mixed signs. What do I mean by mixed signs? The signs, some of them are the same as the original, and some of the signs are the opposite. So if you have a scenario like that in any one problem, then that problem is neither, that function is neither odd nor even. Alright, let's try out some examples. The instructions are for us to determine if the given functions are odd, even, or neither. Okay? Number one, let's say we have the function 3x squared minus 5. So how do we do this? What we'll do is we compose the function with negative x. What does that mean? It basically means that you replace all the x's in the function with negative x where possible. Okay? So instead of 3x squared, we have 3 times negative x quantity squared minus 5. Now let's reduce. We're going to have negative x. Now something you want to remember, let's just put a side note here, something you want to recall, is that when you take a negative sign and raise it to an odd power, the negativity remains, it becomes minus. When you take negative on the flip side and raise it to an even power, it becomes positive because you can pair up all the minuses, and minus times minus is plus. Okay? So here we have negative x, since 2 is even, okay, that automatically tells us that the negativity will go away. So it becomes 3x squared minus 5. Now if you compare the signs of this f of negative x with the original, you see that the signs are equal, is exactly the same. So this function is equal to f of x. So what is the conclusion? Since the function composed with negative x yields exactly the same original function, then The function is what? The function is even in this case. Alright, let's try another example. Question 2. Let's say we have the function f of x equals 3x to the fourth minus 5x. Okay? Alright, so how do we do this? Well, what we're going to do is we're going to use a test. We're going to compose the function with negative x. So that basically means we're going to substitute negative x for all the x's in the function. Alrighty. If we do that, we have 3 times negative x to the fourth minus 5 times negative x. Let's simplify. So we have negative x raised to an even power here, so the negativity goes away. We have 3x to the fourth. And then this power here is 1. Negative x raised to an odd power. The negativity stays, so minus times this minus here becomes a plus 5x. Okay, now let's compare what we have with the original. Now the 3x to the fourth is positive, right? The original is positive 2, so that's the same sign. But if you look at the 5x, this is positive 5x, and this is negative 5x, opposite. In this case, we have a mixed situation with the signs. The first sign is the same, the other sign is opposite. So what is the conclusion? In a case like this, the function is neither odd nor even. Okay, so since f composed with negative x is not equal to the same function, and f composed with negative x is not equal to the opposite of the function, basically all signs flipping, then that tells us that the function is neither odd nor even. Okay, let's take a look at another example. For question 3, let's say we have the function f of x equals 3x to the 101 minus 1 over x to the fifth. So, to carry out our test, we're going to be composing the function with negative x and see what happens with the signs. Okay? So, let's go ahead and do that. We basically replace all the x's in the function with negative x and then simplify. Alright, so this becomes negative x and this is negative x. So what do we get as a result? Negative x raised to the 101. 101 is odd. Alright, so since this is an odd power, the negativity stays. So the minus comes out and this sign becomes the opposite, negative 3x to the 101. And then down here also we have an odd power. So the negativity stays and that minus will be multiplied by this minus here, making it plus 1 over x to the fifth. Now let's compare signs of each term. If you take a look at the negative 3x to the 101 and the 3x to the 101, they're opposites. Okay? And then if you take a look at the positive 1x to the fifth and negative 1x to the fifth, they're opposites too. So they're both opposites. We have opposite signs. Alright? So if both signs flip or are opposites, or if the signs of every term in the function becomes the opposite, then that means the function is odd. Let's illustrate that mathematically. If a function is odd, when you factor out negative from that function, the odd function, upon composition by f of negative x, this is what it looks like. You have 3x to the 101 minus, you will get the negative times the original. Now, this quantity right here, is it identical to this quantity right here? It certainly is. So that illustrates that this function is the opposite of the original. This is negative f of x. Okay? So if f of negative x equals negative f of x, what's the conclusion? The conclusion is, since f composed with negative x is equal to the opposite of the function, and the function is what? The function is odd. Okay, so that's that. Now, how well did you master the problems that we just went over? In order to demonstrate mastery, we'll like you to go ahead and try out the following problems, and then go ahead and click play after you're done trying them out and see if you got it right or wrong. Alright, so the task is to determine, so we're going to try these. Instruction: determine if the given functions are odd, even, or neither. Okay, number one, let's see, you have f of x equals 3x to the third plus 5x minus 2. Number two, let's say you have f of x equals 1 over x to the fifth minus 1 over x to the third plus x. Number three, what if you have f of x equals the square root of x squared plus 1. Number four, what if you have f of x equals the cube root of x plus 1 over x? Okay, so go ahead and pause this video and try out these problems. When you're done, click play and then you will see the answers. Alright, so hopefully you had a chance to try the problems. These are the answers. The first function is neither odd nor even. The second function, number 2, is odd. The third function, number 3, is even. And then the fourth function, number 4, is odd. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of odd and even functions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, place it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. A lot of tutorials and support resources can be found at math.serve.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.